Girls, you ready? Last lesson we were learning about bivariate data and we were drawing some scatter plots. Today we want to go a step further with those scatter plots and we're going to be drawing a line of best fit and using that line of best fit to estimate some other values and also find its equation. So let's start at the beginning. Here it is, bivariate data. When we have bivariate data and there is a strong linear correlation, we wouldn't worry if it was a weak one, we're not going to get a very good idea anyway. But if it's a strong linear correlation, we can model the data with a trend line or a line of best fit. We are going to be using the by eye method. That's frozen. Doing it by eye, you need to balance the number of points that are going to be both above and below your line. So you should always try to make sure where possible that it is, if there's 2 above and 2 below, that's a good way to position the line. You also need to consider the distance that each point is from the line, and it is a little bit of an estimate. Your line might not be exactly the same as the person's next to you, but they should be close. Okay, if you do standard maths next year, then you will learn some other techniques that are a little bit more accurate then. The equation of the line of best fit can be found using 2 points that are on your line. So when you do your line of best fit, we're kind of strategic. We make our line go through 2 of the points, at least 2, so that we can use those points to find the equation. Okay, and you have this formula here that we know to find the equation of a line. If you have a point and a gradient, everyone remembers that formula from our last topic? Yes? It means that you'll also need to find the gradient, which means that you'll probably want this one as well. y2 take y1 over x2 take x1. Okay, so let's find the gradient first and then use the point gradient formula to find the equation. Then, the whole purpose of this is that we want to be able to get some information. And there is a couple of fancy words here. If you do your line of best fit and you get the equation, if you're trying to find a result that is in the data range, so like if you look in here, my x values are between 1 and 7. So anything between those values that's inside my data range, that is called interpolation, because I'm looking inside my data set to find or estimate a result. However, we also want to be able to extrapolate or extrapolation, which means we can extend a line of best fit beyond 7 and we could estimate what would be happening if we went out further to higher results further out. Does that make sense? So that's extrapolation. So we may come across those words. So let's do it. Example number 1. Consider the variables x and y and the corresponding bivariate data. First of all, draw the scatter plot. This is what we did yesterday. Okay, so we have an x-axis with numbers 1 through to 7. So x-axis down here, 1, 2, 3, 4, 5, 6, 7. In case we're going to do any extrapolating, I'm just going to a couple of extra spaces there as well. Then we have our y-axis, which goes up to 5. 1, 2, 3, 4, 5, but just going to extend it a bit further. And we carefully plot our points. So the first one, x is 1, y is 1. Put a dot. X is 2, y is 2. X is 3, y is 2. X is 4, y is 3. X is 5, y is 4. X is 6, y is 4. X is 7, y is 5. Okay. Okay, it hasn't asked me for the line of best fit yet. I'll hold off on that for a second. The first thing it asks me to do, it says, is there a positive, negative, or no correlation between x and y?
Positive.
Positive, good. Increasing as we go from left to right. Positive gradient. They are pretty close together. They're not perfect. but we would call that a positive correlation. Part C says to fit our line of best fit on there. So we grab our ruler.
You just pick the lowest line.
Yes, so you want to try and balance. As I said, you want to have the same number of dots below and above if possible. And you want at least 2 dots right through your line. So, that's pretty close. I reckon that's pretty good actually where I've got it. So with that, I'm going to put mine here. Because it actually goes through 3 points, I've got 2 points above and 2 points below. Okay, the other thing to check out for is that you don't have 2 points above down here and 2 points below down here. It means you've twisted your line too far sideways. Does that make sense? You've rotated it too much. So
I do it wrong then.
Yeah. See how you've got 2 low ones down here and above and 2 high ones?
So where do I do it?
So you rotate it a bit that way. You bring this end up a bit and that end down a little bit.
Like that?
Yeah. So maybe on up this one. So the first one, I've gone through the first one and the last one pretty much. First one and the last one, and it went through beautifully. Okay. Everyone okay with that?
So you just guess.
It is. It's a judgment, yes.
Okay.
Okay. Then from our line of best fit on the next page, it's going to be interesting for me to be able to see it. Shrink it down a bit. It says use your line of best fit to find a few things.
So you didn't just do that.
You fit a line of best fit.
Oh.
So that was the line that I drew on there. So that's the green bit. So part D, use your line of best fit to find these things down here. So we want to find y if x is equal to 3.5. So because your line of best fit might be slightly different, you need to show me that you're reading it off in the right place. So the best thing to do is to draw a little dotted line. So x is 3.5 is here. So you're going to go 3.5, I'm going to go dot, dot, dot up and dot, dot, dot across. And as long as the value you tell me, oh, you can't see that because it's shrunk down so much. Well, still can't see it. So on my graph, that looks at about 2.7, 2.8 maybe. The reason you need to show me that is because as long as it looks reasonable from what you have drawn, then you will get it right, even if it is different to the person next to you. Okay? It's all about your graph. So that one, I got about 2.7, I'm going to say. Y equals 2.7. So then we want to find y when x equals 0. So this is an extrapolation, isn't it? Because my lowest value was a 1, I'm extrapolating, I'm extending my line out here so I can read what is happening when x is equal to 0. What's y equal to? What do you guys think on your graph? 0.5? Yeah, about 0.5 or 0.4, maybe slightly below, somewhere in that vicinity. So y equals 0.5. Okay, now we're going to switch it around. We want to find the x values when y is equal to 0.5. So I'm going to be up here. Let's change colours so I don't confuse everybody. Pink, no red. Red's good. Okay, so 1.5 for the y. I'm going to go dot, 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 dot across. Dot, 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 dot down. What do we get?
2. I got 2.
You got 2? Mine's below 2. Mine's below 2. I think that's about 1.8. So I got x equals 1.8 for that.
So if we were a couple decimal points out, would you still give us?
I look at your graph. So that's why I need to see where you've drawn it. So the first thing is it shows me that you've gone 3.5 is definitely here. So I know you've looked in the right place. You've gone up and you've gone across. So as long as you've done that correctly and that result looks reasonable, then you'll get it right. So the last one was y equals 5.5. So from the 5.5 all the way across, make sure it's nice and straight. And down. Mine looks like it's about 7.8.
Oh, so
Yeah.
Maybe you trigger line mason there. Oh, it's me.
Okay, so that obviously, because we can have our lines in slightly different places, it's not the most ideal way to do it. And even drawing those dots on there, the scale is not very precise. Like there's, 0.1, 0.2, it's very hard to guess between there what each of those decimal places are going to be. So it's much better if we actually find the equation of the line. Now, to make sure that we all get the same results, here's a second one with the line on there for you. Okay, so we all have to get the same for this one because we're all going to use that same line of best fit. Okay, so it says the scatter plot shows a linear relationship between maths marks and science marks in a small class of students. A trend line passes through, okay, this is important, it's giving me 2 points that my line is going through. I'm going to have to use that to find the equation. Part A, find the equation of the trend line. So first of all, we need to know the gradient. So I use the m equals y2 take y1 over x2 take x1. You could technically, you have got a diagram there. If you want to draw a triangle on there and do a rise and a run, you are welcome to do that as well. But I'm going to use the points. So up here, x1, y1, x2, y2. So y2 was 50 minus y1, which was 20. x2 is 50 minus x1, which is 30. Okay, and when you calculate that, it comes out to be about 1.5 or 3 over 2 if we want it left as an improper fraction. That's the gradient. To find the equation, I now need my point gradient formula. Y minus y1 equals m, bracket, x minus x1. So I'm going to use the x1, y1 as I've labelled them up there in the words of the question. So that's going to be y minus 20 equals, I'm going to use the decimal, 1.5 x minus 30. Expanding that out, you get y minus 20 equals 1.5x, and 1.5 times minus 30 is minus 45. The last thing to do is to move the minus 20 across so you get y by itself. We want a y equals equation. So y equals 1.5x minus 45 plus that 20 is going to be a minus 25. So that there is the equation of that line of best fit. Now, if I want to know things from that graph, I no longer have to come up here and try to, read it off here, how accurate can I be? I can sub things into that equation. Okay, and that's what we're going to do for part B and C. Remember that, and you might want to make a note, the Y is representing the science mark, because that was what was on the Y-axis, and the X is representing the maths mark. So part B says, use your equation to estimate the maths mark if the science mark was 30. So remember the science is the Y. It means I'm subbing the 30 where the Y is. So it's going to be 30 equals 1.5x minus 25. Now, I guess this is squished in here a bit, so we didn't want to take an extra page. We've got to try and squish in solving that equation to find the x. So first of all, you want to do a little plus 25 to both sides. Some of you still like writing those little instructions down. So that's 1.5x equals 55. And then I'm going to go over here. I divide by the 1.5. So x equals 55 divided by 1.5 is 36.7. Yeah? One more, part C. Use your equation to estimate the science mark if the maths mark was 90. So that 90 is now going to be the x, because maths is the x one. So we sub that in. y equals, the formula was 1.5x, so 1.5 times 90 minus 25. Luckily, there's no rearranging for that one. We just type that in our calculator, and that's a mark of 110. Okay? So you will be told in the question whether you need to find the equation and then use the equation to estimate the values, or whether you need to use your graph and just be drawing those little lines on there trying to estimate as best you can.